Hi everyone, I am Pawan Omkar. Now we are going to present a project about the building and Python interpreter here. Like this was presented by the few members of my teammates. Uh, those are the teammates are the Aditya, Shreya, Chaitanya, and myself, Pawan Omkar. And this is in the particular course of advanced programming language. And come to the first slide. This is all about the introduction. In this introduction, we only worked on the four different parts. The first one is like the lexical analyzer and the phraser and the parser and the AST abstract syntax tree. And the fourth one is the interpreter here, like which I mainly worked on the interpreter. So this project implements a simple interpreter for a custom programming language that supports variable assignments, the arithmetic operations and some print statements here. When come to the overview, the when come to the objects of this particular project, the first one is we have to design and implement the core components of an interpreter here. Like it includes lexical analysis, syntax parsing, and the execution. It is to process and to execute a simple language here. And the second most key objective is like to create a structured or reusable interpreter with separate modules for the lexer parser and the AST and as well as the interpreter logic, followed by uh, ap- apply programming concepts to handle variable assignments, arithmetic operations, and print statements, showcasing real-world applications of interpreter design. When come to the workflow of this project, as I said before, we are working on the four different parts. Uh, this first one is the lexical analysis here, like which mainly converts the inputs into the tokens. And when come to the second part, it's called the parsing of parser. It mainly builds an AST from the tokens which already converted by the lexical analyzer. When come to the evaluation, uh, this evaluation comes under the part of the interpreter, like which traverses the AST and execute instructions. Rest will be continued by my teammates.
Hello everyone. So coming to Lexer is also called as lexical analyzer. It is the first phase of the interpreter or a compiler process. So its purpose is to take the raw source code and breaks it into tokens. These tokens are small meaningful units in which the program include keywords, identifiers, operators such as plus, minus, subtraction, equals to, etc., numbers, and punctuation such as semicolons, left parenthesis, right parenthesis. Uh, Coming to next one, the role of the lexical analyzer in our project is first one is tokenization. The lexer breaks down the input program into tokens. And that can be sent it to parser. So, like for example, if we take let x equals to 10 plus 5, so here let is uh, let is a keyword, and this id x is a variable which is id, uh, equals to is assignment variable, so equal to is assignment, uh, 10 is a number, the regular number, so it's a number, and plus is an operator, so we have a token called op plus that we used, and 5 is a number, so number 5, and it ends with the semicolon, so we have added the semicolon as well. And then for the print statement, it prints like print, it's a regular print statement, so print left parenthesis, which is shown here, and x is an id, right parenthesis and semicolon, and ends. This is a role. Then the filtering of input, it removes the white spaces or and ignores irrelevant characters like comments, or to ensure the clean input for the next stage. This prevents unnecessary complexity during parsing. So the other step is standardization. Uh, the Lexer ensures that it consists of format for the input program by translating into text into well-defined tokens, and then it builds the blocks. These tokens are generated and are the building blocks for the parser to create a parse tree or abstract syntax tree. The next will be continued by Shreya about the parse.
In this slide, we'll discuss about parser. A parser is a tool used in compilers or interpreters. It works after the lexical analyzer, which breaks the code into a smaller pieces called as tokens. The parser organizes these tokens into a tree-like structure called as the AST, which is abstract syntax tree. This AST shows the relationship between the different parts of the code, like flowcharts for understanding the code structure. Um, the importance of the parser is it checks the correctness, makes sure that the code follows the proper syntax like grammars or programming. It makes the code understandable, which converts the code into a format that the computer can analyze it easily. It prepares for the further steps and identifies the errors. The use of the parser in the compilers or interpreters is it ensures the proper syntax and it helps to build the complex programs. It organizes the code into an easy to process format for the computer. It also improves the efficiency. And coming to the next slide, the role of the parser in this project is it validates the syntax, like ensures that the variable assignments, the arithmetic operators, and print statements are written correctly. Like, for example, if we take a statement which is x equal to 5, it must end with a semicolon. It builds the AST, converts the tokens into a tree like structure that shows how different parts of the codes are related. This AST organizes the code for easier understanding and processing. It checks the grammar rules and it converts the flat tokens into a structure, takes the raw list of tokens from the Lexer as an input and arranges them into a structured format, and it prepares for the execution. The parser organizes the code so that the interpreter or the compiler can process it step by step, and it also detects the errors, finds and reports the missing semicolons or the unmatched brackets to help fix the mistakes early. And coming to the next slide, parser. Here, a parser takes the tokens generated by the Lexer and organizes them into a structured format called as AST. This AST represents the hierarchical structure of the code, showing how different parts are related. In this example, uh, we can see the inputs of tokens, that is let, which declares the new variable, and the IDX, it is the name of a variable, and we can see the numbers 10 and the 5 and a plus operator. By taking this input tokens, we are giving the output AST. This AST is written in a single line. This AST is important because for the organized structure, which converts the tokens into a logical format that can be processed, and it is easy to understand, and it supports the later stages. The AST is used by the interpreters to generate the machine code or directly execute the program. Coming slides will be explained by my teammate.
Yeah, Aditya, next slide. Yeah, coming to the AST, it is a three-type structure that represents a logical organization of source code. And it represents away the syntax and focus on the underlying meaning of the code. Key features: each node represents a construct in the code, like operators, variable, and statements. It provides a simplified structure for interacting or compiling code. Use of an AST. It is used to execute or translate code by organize it into a structured format, and it is illustrate the relationship between the components of the code, such as how operators apply to variables, example x plus y or x is equal to 5. Aditya, next slide. Yeah, okay. Yeah. Coming to the role in the project, the system organization a program into the key components such as variable assignments, arithmetic operations, and print statements. These components, known as a node, serve as an input for the interpreter to run the program. Especially, it connects to the two main stages of a program: execution, pricing, where the code is analyzing, and execution, where the program is carried out by breaking the code into the distinct nodes for calculating variables and output. It ensures that interpreter can efficiently process and execute the program. Designed class for AST nodes and ensuring capability between the nodes and the interpreter. Next slide, Aditya. And coming to the example, here we took let x is equal to 10 plus 5, print x. Here x is an assigned node and x plus y is an arithmetic operation. And we used coming to the print x, we use print statement. Yeah. Next will be continued by Pawan.
And come to the final core part, which is the interpreter. We all know an interpreter is a program that reads and executes the code written into a high-level programming language, line by line. It converts it into a form that the computer can understand, which it converts the mission code into an intermediate representation, like the mission code into a regular code. Uh, Next slide. Yeah, the role of interpreter in the project. The first thing, it manages the valuable variable storages, and it performs many operations, like which we all know, the arithmetic operations like the addition, subtraction, multiplication, like that. And finally, it prints the results also in the ending, and it mainly evaluates and executes the AST created by the parser in the second module. Or later on, it acts as the core part of the project, which is turning code into actionable output. And then it provides output for arithmetic operations, as we already told, like the different operators as for the BODMAS rule. The next slide. Yeah, this is the example of the interpreter here. In this, the complete statement is we are taking as let x equal to 10 plus 5 here. We are printing the value of the x here, and we are using the different arithmetic operations like the equals to and the addition operator, and we are using two integers like the 10 and 5. So we have to print the value of the x. So after doing this complete statement, like the value of the x equal to 10 plus 5, by doing the addition operator, it comes 15. The 15 is the output, which this complete process will be done by the interpreter only.
Coming to the slide, we have included a sample test case in our project. We took the example code, this one. We took two variables which are x and y, and we just added both of them, and we just printed all those three variables. In the lexical analyzer, we'll get this output. It will just explain each and every variable, assignment operator, and all of them. And as well as we'll have a parser output like this. It will generate the tokens over here. We can see for identifier for everything, and also as well as it will provide the ASTs over here. We can see it assigns the node for everything X, Y, and Z, and we just print everything over here. In interpreter, we'll get the outputs X value as 5, the Y as 10, and the Z value X plus 5, which is 15. Now we'll see the practical demo. It will be explained by Aditya.
Coming to the practical demo, can you see this? Everyone can see this, right?
No.
No.
No?
Yeah. Now it's fine.
So these are the codes that we have created or generated. So coming to the Lexer, here we have taken the input, predefined input like everything, and we have created everything like assigned every variable, the plus assignment variable, plus minus and multiplication, division, parenthesis, everything in this Lexer code. And coming to the parser, the parser code was executed by Shreya, and she has done the assignment variables and to create the next abstract syntax tree. Then coming to interpreter, or no, coming to abstract syntax nodes, these are obtained from the parser. So this was created by Chaitanya, and then at the end, the interpreter was generated by Pawan. So coming to the final execution of this project, we have taken the test cases as the execution example. So since we use Python as an interpreter, so Python space test one dot p1. So for the first test case, we have uh, like assigned variables previously as well. So we have got like we have assigned x equals to 5, y equals to 10. So the output is 15. So to get this output, we have created like in the Lexer, we have created let x, and everything is assigned to each of it. And in the parser, it was converted, and abstract nodes are generated. Finally, we get the output as 15. So, like in the same way, we have created for the we have made two more test cases for to pass this code. To right. The same way we got this in this like let me show you the test case. In this, we have used a equals to 10 plus 5 into like BODMAS rule, what comes first and what comes last. So at the end, we got the result for the second test case as well. In the same way, we do this for the test case 3. and again we got the same output. So tokens are generated, and in the parsing phase, the token these tokens are consumed and used at the in the no abstract syntax tree. The nodes are generated, and finally we got the output as 2 plus 10 equals to 5. 0. That's it. Yeah, thank you.